Hello everybody, this is Dr. Barnes, and since we don't have lecture today because of inclement weather, I'm going to do a lecture and post the video on Blackboard so y'all are able to still access the content and we can move forward with the class. What we're going to focus on today is maps as a tool for geographic inquiry. So I'm going to do a short lecture that looks at maps as a tool and considers the construction of maps, and then we'll do a short discussion activity on Blackboard, and taking part in that discussion will get you your attendance grade for today. So to get started, I want to give a definition of maps. A lot of us have some concepts of maps because they're something that we use often in the world, but to just put a specific set of terms behind it, we can think of a map as a graphical representation of a cultural or physical environment. And we have a couple different images here that give us examples of a few maps. The map on the left is an artistic map of Brooklyn, and it shows the different areas within Brooklyn. You wouldn't want to use it to have to get around town, but you might want to hang it on your wall. The map on the right is a historic map of what folks thought Africa looked like a long time ago. So we can see that maps can be both useful and convey a lot of information and be quite beautiful. The practice of making maps is called cartography. And it's important to think about cartography as both a science and an art of map making. It's a science in terms of wanting to have accurate representations and data collection, but it's also an art in terms of making design choices in trying to find ways to put a map together that's aesthetically pleasing as well as conveying information. So folks that make maps go through a process of collecting data, designing the map, and then constructing the map. A lot of us use maps on an everyday basis, though more and more we don't use paper maps. We often use maps that are on our phone or through a computer, things like that. In thinking about these maps, we can think about what we use maps for. Often wayfinding, getting directions from one place to another, is one of the most important uses that we use for maps. A lot of us use our phones and the GPS, the global positioning satellites, to position us within a map that's visualized on our phone. There's also government and tourist maps that convey information about where things are and how to get there, and informational maps. The thing that's interesting about GPSs, global positioning satellites, and our phones is often what happens is, as long as the receiver that you have, that might be a phone or a standard GPS, can connect with 3 of the satellites that orbit around the Earth and convey geographic information, your location can be triangulated anywhere on the surface of the Earth, and it can tell you where you are. So you're seeing not just a static map, but a map that shows your relative position within it, which helps us find our way around for sure. But often our phones actually don't have a true GPS, and instead phones will get our location based on the location of the cell towers that we're connected to. So often if you have a real GPS, you'll be able to find your location almost anywhere because it connects to those satellites, whereas we might have spotty coverage in terms of cell coverage for the GPSs that we often use on our phone. Video game maps are also important. A lot of us are gamers, and we navigate worlds that aren't just the real world, but computer created worlds through things like video games. For me, I was a big NES, Nintendo player back in the 80s, and it was always important in The Legend of Zelda to get the map in the dungeon so you knew where you could find the boss and the treasure and all that kind of fun stuff. And another way that we use maps is Geographic Information Systems, or GIS. And GIS can be used not just for things like wayfinding, but also for analysis. And you all have hopefully watched the Geographic Information Sciences video from last week to get a sense of some of the things that GIS can do that ties data to locations on a map for analysis. Here's just some examples of maps we might be familiar with. This is the Google Maps view of Flagstaff. And here's another version of a Google Maps view, and we see the change in terms of what the background is, so we can actually see the remote sensed image of this area, as well as an overlay of different streets and main roads, those sorts of things. Here's a map that is of the London Underground, their subway system. And it's really an interesting map because it's not really tied to what you see on the ground if you would be in London. Instead, it's very much pared down to be only the information about the specific tube lines. It's color coded for the different tube lines, and then the circles that you see are related to the different stations. You have things like the River Thames, that thick blue line that runs through there, running at strange right angles that has nothing to do with what's on the surface, but it's a really useful map if you're trying to just get around on the tube, but won't do you much good if you're on the surface in London. Here's another example of a map. Maps can not only be used for wayfinding, but to also convey information. So, for example, this map has created categories that show the approximate distance from the Mississippi River and color-coded states based on that, and then created prisms below the states that show the number of confirmed human cases of West Nile virus. So you can really quickly begin to see associations here between location near the Mississippi and the prevalence of human cases. Here's another map that is something called a flow map. It shows labor migration flows in the greater Mekong subregion of Southeast Asia, and you can see the initial cities that migrants start from, and then the movement of those folks to other parts of Southeast Asia as well as the rest of the world. So this is something to keep in mind, these categorical maps as well as these flow maps, as you think about doing a current event assignment later in the semester where you'll have to create maps to convey these kinds of information. We'll just skip that one. We talked, mentioned briefly before, again, geographic information sciences or systems, these computer-based systems that process geographic information and analyze data. And, hopefully you watched the video on that last week to have a sense of it. One of the important things that I want to highlight in this class is that maps are a social construction. Often we take maps for granted as being accurate to what's on the ground, but we have to remember that the mapping process is a process undergone by people. So our prejudices, our education, our social relations, relations of power go into map making. Often maps were created historically for social control by people in power. The process of gathering the information to create a map and to be able to explore a place to gather that information often was very expensive. So it was done by governments. With the internet and cheap computer technology, mapping is more available and has been somewhat democratized, whereas more folks have access. But it's still in some ways a tool of surveillance, so we can know where people are, where resources are. And maps can also be used not just to tell people where they can go, but to tell people where they can and can't be. So for example, if you've ever gone to a tourist destination and picked up a paper tourist map, it'll often have a lot of detail in the parts of town that are the sort of designated tourist areas, and very little detail beyond that, in a way to try to control how we move through that space and where we stay and spend our money. Another thing that's very important in thinking about maps is that the world is round and most maps are flat. So decisions have to be made by map makers in terms of trying to figure out how to manage the distortions caused by moving from a round world to a flat map. One of the ways that we can visualize this is we can think about peeling an orange. So with an orange, you've obviously got a round object. You take off the peel, and if you tried to lay that peel out flat, you'd have some strange shapes. A similar thing happens as we try to make maps from the round world. Here is an example of some of the ways that cartographers had tried to manage these distortions. One of the most popular maps that's used is the Mercator projection, and that would be formed by the cone shape, or sorry, the circular shape of the paper around the globe on the left. Imagine if there was a light bulb in the middle of that and the shapes of the continents were cut out. The light that was cast on the paper that was wrapped around the globe would give you the image on the right, which is basically the Mercator projection. And I'm going to add a video online that you all can watch too that gives a little bit of a description of some of this process using a fictional show about the White House, where they have activist cartographers coming and talking about different map projections. So I'll post that as a separate video as well. The thing with the Mercator projection is, again, because it creates distortions, it shows us things that don't really jive with what's on the ground. So for example, with the Mercator map, it looks like Greenland is larger than Africa, but actually Africa is over 10 times as big as Greenland. What the Mercator map does is it distorts areas near either the North or South Pole. So there's multiple different map projections that folks can use. Historically, folks would use the Mercator projection because it made it easier for folks to travel across an ocean. But here are some other possible map projections. And so in any case, you often find things that you have to give up. There might be distortions in terms of area and distortions in terms of distance, the distortions in terms of direction, those sorts of things. Your book goes into some detail about the different projections, and I'm not going to spend too much time here on that today, but I'm going to skip forward to thinking about what goes into a good map. Oh, and also, sorry, different ways of visualizing. So one of the things that we also tend to see in looking at maps is we have sort of preferred visualizations that we're used to and we use a lot. This is an example of a different way of visualizing the world. You see the North Pole at the center of the map, and perhaps it gives you a different view of what's there in our relationship to each other. Here's another way of visualizing, folks would say, is upside down, right? So you have a south-oriented map rather than a north-oriented map, but there's not really necessarily a important reason that we visualize it to the north. It's just the norm that we use for map making. Another way that we can think about maps and visualizations is the categories that we use to understand data. So this is a map of presidential election results from Obama versus Romney. We see the red state, blue state divide, colored based on what state got what party got the majority of votes for that state. So it gives us kind of a divided view of the country. Here's some other ways to visualize election results. So this is that same election. We have a few different visualizations. In the top left, we have that visualization by state majority that we saw before. Going down, we see then that division by county. So we begin to see that it's perhaps more nuanced than that initial by state example. And then we see by county, percentage by county, showing kind of a gradation. Then the main map in the middle here, we see nuanced election results because it's colored by population density. So rather than seeing that red state, blue state divide, we can see that the places where the majority of the population lives, many of those places voted for the Democratic candidate. We can also see that in a lot of places, it's not so much a red state, blue state divide, but the states are rather purple, right? So the division isn't necessarily as stark as it first appears. So again, interesting to think about the decisions made in how that data was represented, giving us a different view of what's happening in a place. I'm going to pause here, and then we'll do a second video that goes on with the remainder part of the lecture.